This is Mr. Hill with another linear relations tutorial. By the end of this video, students will apply data management techniques to investigate the relationship between two variables and will determine some of the characteristics of linear relations. Some of the specific expectations that we'll be working with will begin posing problems, identifying variables, and formulating hypotheses associated with relationships between two variables. So we're going to continue with our sample block pattern investigation. And the question that we're thinking about is the relationship between the number of blocks in a sequence of shapes linear or nonlinear? Let's do a little recap of some of the things that we learned in our previous video. We talked about how a relation is a pattern between two variables. Right? We can express it as an ordered pair, okay, a table, a graph, and an equation. And so for this video, we're going to focus on how we can express it as a table and a graph. Remember, we started off with just 3 shapes in our sequence. When we began our investigation, we extended it 3 more shapes. One of the things that we started to do when we examined our pattern is keep track of the number of red blocks and the number of green blocks. As we moved from shape to shape, we realized that we were adding 1 red block and 1 green block to each shape. To be able to write this as a set of ordered pairs, we declared some variables, x and y. We let x represent the number of red blocks and y represent the number of green blocks. This allowed us to express each pattern in the sequence as a set of ordered pairs. As we added each shape to the sequence, we added 1 red block and 1 green block to each shape in the sequence as we progressed. Notice that we added the same numbers each time. X always increased by 1 and y always increased by 2. This is called a constant rate of change, and it is one of the characteristics of a linear relation. So the examples that we'll be looking at in this video will illustrate what a linear relation looks like as we move it into a table and as we move it into a graph. If x represents the number of red blocks and y represents the number of green blocks, we can express these ordered pairs in the form of a table, where our first coordinate is 1, 8, our second is 2, 10, our third is 3, 12, our fourth is 4, 14, our fifth is 5, 16, and our sixth is 6, 18. We've now shown how we can represent our block pattern as a set of ordered pairs and also as a table. Let's see what it looks like on a graph. If I plot the point 1, 8, I need to let x represent the number on the horizontal axis and y represent the number on the vertical axis. This will allow me to plot my points. Our first point is 1, 8. 1 for x and 8 for y. Our second point is 2, 10. Where 2 is the x-coordinate and 10 is the y-coordinate. Second point is 3, 12. Our fourth, 4, 14. Our fifth, 5, 15. Notice that we're moving over 2 blocks and up 1 block each time. My next point should be right here. Yep, you're right. What is this starting to look like? Any ideas? Before you answer that question, let's start to think about some of these questions down below. As the number of red blocks increases by 1, what is happening to the number of green blocks? As we moved from shape to shape, the number of red blocks increased by 1. Where at the same time the number of green blocks increased by what number? Yeah, you are right, 2. So as the number of red blocks increases by 1, the number of green blocks increases by 2. Our next question asks, is this relation linear or nonlinear? Well, one of the things that you can do is take out a ruler, right, and see if you can connect your points. I'm going to use my line tool. Then I start at my first point and draw right through to my last. It looks like I can draw a nice straight line. So one of the things that we need to understand is that if we have a linear relation, it looks like a straight line. So to answer the question, is this relation linear or nonlinear? Well, this relation is linear, right? Because it looks like a straight line on a graph. Our next task is to predict how many green blocks will be in the stage with 8 red tiles. Well, there's a couple different ways that I can do this. I know how many blocks are in my 6th stage, and so I know that if I can continue to my 7th stage, I'm adding 1 red block, and I'm adding 2 green blocks. 18 plus 2 is 20. To get to my 8th stage, I can repeat the process. I can add 1 red block, and I can add 2 green blocks. 20 plus 2 is 22. We'll have 22 green blocks in the stage with 8 red tiles. So one of the nice things that we can do when we have a linear relationship is predict how the pattern will continue. So just to summarize, when we have a linear relationship, our variables increase at a constant rate. That means we have a constant rate of change. Our x variable increases by the same number each time, and our y variable increases by the same number each time. Also, when we have a linear relationship, we have a straight line on a graph. So when we have a constant rate of change and our relationship looks like a straight line on a graph, we have a linear relationship. Before we finish, let's consolidate some of our learning and bring together everything that we've talked about so far. So when we have a relation, we can express it as an ordered pair, a table, a graph, or an equation. We also saw that when we have a linear relation, our variables have a constant rate of change. We also saw that when we represent a linear relation on a graph, it looks like a straight line. When we have all these things, we can make predictions. So there's a good introduction to linear relations. And stick with this playlist and we'll practice some more examples about how to use some of these tools and apply some more of these concepts.